Okay, as I mentioned, state machines are trickier than fault trees. This one you probably will want to find a good example for, or a textbook with a summary of it. Maybe not the whole thing, but okay, maybe the whole thing. Uh, you can get a really quick and basic thing looking at Wikipedia. I'll do my best to give my take on it. So, in a UML state machine, okay, let's see if I can break it down into pieces. States and transitions. Yeah, that'll work. States and transitions. States will be boxes, bubbles, whatever, a whole bunch of them. Transitions will be the lines that connect them. Transitions will have a direction on it. Go from this state to this state to this state or this state. Next to transitions, there will be a condition when you take this event. As in when X happens, follow the transitions, you are now in this state. I will probably misspeak and say event instead of state. I mean state, really. When you look at a state machine, you should try and find the little black dot, or possibly a transition that comes out of nothing, and that'll tell you what state to start in. You will remain in that state until some event pushes you someplace else. If you can find an example for this, you can get the gist of how state machines work pretty well. I'll see if I can actually get an example I made a while back for it was a humorous imitation of my attempt to return home. But if you look at it, you can kind of get the basics, if in a silly way, of what these are supposed to look like. Can I get that up here? Oh, there you go. Now you can pause it if you want to see that. Anyway, so that's the basics of a state machine. You have things that are happening, you move from one place to another. That's reasonable for the basics. Let's see if we can't get a little bit complicated now. So one or two things make state machines a little more complicated than what I've said so far. Machines within machines. I'll explain that in a sec. Actually, no, I'll explain that now. So, normal state machine, you have the state machine. Great big thing here. The state machine contains all of the individual states and events and transitions. Sometimes, instead of having your state be just a single state, it'll be a smaller state machine. When this happens, you enter your state machine, you follow your states, you hit this mini state machine, then you enter that machine as if it were its own brand new state machine. Find the starter point, and you go around here all however you like, and you will stay there until some event kicks you out of the state machine or it points you out. For example, if you get to this, tongue-tied. Maybe you're running a program, you enter, let's say enter game mode. This is a game, you go from menu, enter game mode. You're going around, bouncing around, doing your game and whatnot. And then outside of this state machine, there'll be a transition of power cut, shut down. Something from the outside causes it to stop. Then you'll immediately yank yourself out of this, follow that transition, and be back in the larger state machine. Whereas if you just had the state machine by itself, if this thing wasn't inside something smaller, it would kind of break when something outside of what it contains happens. So for that reason, you'll sometimes need state machines inside of state machines. Hope that makes sense. If not, look it up. Sorry, just look it up. If you don't get it, you need to know it. Another thing about state machines that makes them a little complicated, and this is really, really important, are parallel state machines. Wong has told us many, 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 many times, you need to know parallel state machines or this whole project will not work. Anyway, so what makes parallel state machines special is that in a normal state machine, you can only be in one state at a time. You're here, or you're here, or you're here. Parallel state machines, you don't have to be. Imagine your state machine. Inside it, you'll have a smaller state machine. This state machine will be sectioned, broken up by little dotted lines. When you enter this mini state machine, you will start in each of those sections. Imagine, if you will, the fault tree, where you have your basic events, and those connect over to intermediate events and that to the top level error. Imagine in this little state machine, all of those little sectioned events, each one is going to represent a basic event. When you enter the state machine, every basic event, every little section you have in here will have its own little starting point black dot, its own starting event. All of them will move to the first state, and then move to another state or another state. You can have a whole bunch of these things going on at the same time. Crazy. Which for us is useful because when we do this, we like having only two states in these parallel state machines. Statement is true, statement is false. Statement is true, statement is false. And if all of them are true, well, that can connect to a gate. Oh yes, that's another thing. You can totally put gates. In a way, you can put gates inside a state machine. This thing, look up Petri nets. The short version of this is, it's a way, if you imitate this, you can kind of put gates inside of state machines, and that's really cool. Well, it's useful, it's weird, but it works in the bizarrest way. Parallel state machines are useful because you can do multiple things at the same time, and that's not normally allowed. These Petri nets, or an imitation of it, you can start mixing them back together again. An idea that was had a while ago, and I think this is what Wong really wants to do. I could be wrong. I probably am because we didn't finish in time. Is he wants to take the state machine, put a fault tree in state machine form, write it in that way, that can connect out, and now you have the entire fault tree as a state machine. And when you want to tie state machines into fault trees, if you can just up and turn this into a state machine, that'll make the mixing together a whole lot easier, and parallel state machines will allow you to just bam state machine it. So yeah, you've got machines inside machines, you've got parallel state machines doing different things, you've got the Petri net-like things. What those will look like when you come and dig them up. Basically, you'll have parallel state machine events here and here, and then you'll have transitions leading outside of the parallel events into some other thing. Two arrows will be either come together and go to a single event. That way, if either one of these are true, they'll automatically hit the transition. Bam, you're in this thing. That's like an OR gate. If either one is true, this gets triggered. Sometimes the transitions will come together into a little vertical line. And this is for all intents and purposes an AND gate. What it means is that little bar means you must have all of the transitions coming in together, and then you'll send over and come to the next event. That's pretty much an AND gate. And if you can imagine it, the smarter of you, which is all of you, can, the tongue-tied, sorry. Smarter of you can now kind of see how you could take a fault tree, turn it sideways, the basic events over here, top level here. Now these all become parallel shape machines, and they just kind of flow and mix together, combining at each of the gates until you get up to the top level event. And that's kind of cool. I want to talk more about state machines, but as I mentioned, I'm not perfect at this. Really, you'll just have to learn by working and reading. That's my take. If it was useful, great. If not, sorry. You'll just have to start over like we did. That's it. Okay then. I think next would be talking about what we did, what our work was, how we approached things. That'll be fun. That will be fun.